Hello friends, today's question. A particle moves in xy plane under the influence of force such that its linear momentum p of t is equal to a, and this is I unit vector cos of kt minus j unit vector sine of kt, where a and k are the constant. The angle between the force and momentum is. So we have given the momentum p, which is time dependent, and we have to find out the angle between the force and the momentum. So we can say that momentum is given as a cos of kt I unit vector minus a sine of kt j unit vector. And between the force and the momentum, we already know the relationship. Force is equal to derivative of momentum. So you can say force is equal to derivative of time dependent rate of change of momentum. Force is equal to rate of change of momentum. We substitute the value of p, that is momentum, in this equation. We get a cos of kt I unit vector minus a sine of kt j unit vector. And after derivative, we can say our force is equal to derivative of cos is minus sine, so this is minus a k, sorry, f is equal to minus a k sine of kt I unit vector minus a k sine will be cos, so this will be cos kt j unit vector. So this is the value of force, or rather we can say equation of the force. And next, in order to find the angle, we know that if we have two vectors a and b, then dot product of this vector will be given as magnitude of a multiplied by magnitude of b and cos of theta, where theta is the angle between a and b. Where theta is the angle between a and b. So let us one by one find out both the magnitudes. A, let us suppose consider is force. So we can say force, its magnitude will be equal to, we have minus ak, this will be sine of kt whole square plus minus ak cos of kt and whole square and its square root. So we can get this as a square common, taking a outside, inside will be left with sine square kt plus cos square kt. Therefore we can say our force, its magnitude will be equal to ak. Similarly, we can say the magnitude of the momentum will be equal to a cos of kt whole square plus minus a sine of kt whole square and its square root, which will be coming, obviously, similarly, it will be coming as a. So momentum magnitude is given as a. Next, we find out the dot product of a and b, or means dot product of f and p. So we can say f dot p will be equal to, this will be coming as substituting value of vector a, which is vector f minus a k sine of kt I minus a k cos of kt j dot product, and p is our a cos of kt I minus a sine of kt j unit vector. You can clearly see from here that the dot product of f p will be equal to 0. So we almost got all the relative values. Therefore, we can say our f dot p will be equal to f vector magnitude, p vector magnitude, and cos of theta. We have this product is equal to, dot product rather is 0. Magnitude of f is ak and of p is a multiplied by cos of theta. So this will be coming as a square k cos of theta, and it is given that a and k are the constants. So from here we can say that therefore cos of theta will be equal to 0, or we can say our theta will be equal to pi by 2, or we can say it's equal to 90 degree. So this is the angle between force and momentum. This is the angle between force and momentum. Therefore, option D is the correct option. So we can say option D is correct option. So this completes the question. Thank you.